Imagine I hand you a single word on a card, spring. Without any other clue, what does it mean? A season, a coil, a sudden jump, a plumbing fixture? You could be right in multiple ways, but the card alone doesn't tell you which. Now imagine that instead of a word on a card, you have a single column in a dataset. The column header is event type, and one of the values is spring. The same ambiguity exists, and this ambiguity lives at the heart of context dependence in data semantics. Context dependence is the idea that the meaning of a piece of data often depends on the circumstances around it, the other fields in the same record, the system that produced it, the time and place it was recorded, and the downstream use cases that interpret it. In other words, data rarely carries its full meaning inside its own bits. It borrows meaning from where it lives. Let's make that precise. Earlier in this series, we separated syntax from semantics, and we split semantics into explicit and implicit. Context dependence is the mechanism that links those concepts together. Explicit labels are interpreted differently depending on implicit context. A value's interpretation is a function not only of the value and its declared type, but also of provenance, neighboring values, business rules, and the temporal and cultural background of the system. Why should you care? Because many production failures, model degradations, and analytic surprises are not bugs in code or math. They're failures to account for context. Here are 3 concrete cases. Case 1. Time zones and timestamps. You receive a column called timestamp. In one dataset, it's local time, recorded by a client in Tokyo. In another, it's UTC from a server in Ireland. If you aggregate, align, or compute durations without knowing which context each timestamp belongs to, you'll get garbage intervals. Or worse, subtle off-by-hours mistakes that lead to incorrect billing or incorrect causal inferences. Case 2. Currency and localization. A field named price with value 100 could mean $100, 100 Japanese yen, or 100 euros. The surrounding context matters. The country column, the marketplace from which the record originated, the pricing locale. If you analyze conversions or rank products without that context, your insights will be misleading. Case 3. Sensor context. A numeric reading, 0.12, from a pressure sensor has meaning only when you know the unit, the calibration, and whether the device was recently replaced. 2 sensors of the same model can be configured differently. An API may silently change a sampling rate. Context. The metadata about how the measurement was collected is essential. So how does context dependence manifest technically? Several patterns recur. First, local context. The other fields in the same row disambiguate meaning. A value column coupled with a metric type column becomes interpretable. The pair encodes meaning together. Designing data models that encourage self-describing records, where keys and qualifiers travel with values, reduces ambiguity. Second, system context. Which service produced the record matters. Different services have different conventions. Attach producer metadata, a source system or producer ID, and maintain documentation for those producers. That lets consumers apply the correct interpretation logic. Third, temporal context. Meaning can change over time. A Boolean flag is active, may have used to indicate logged in within last 30 days. Later, it might change to has a paid subscription. The timestamp of a schema change is part of the context. Without it, historic data becomes risky to compare with current data. Fourth, cultural and domain context. Units, phrases, enumerations, and codes can be domain-specific. A grade field might be a letter in one dataset and a percentile in another. Language and culture matter. Date formats like 03/04/2025 mean different days depending on locale. If context is so important, what practical steps can you take to manage it? Here are concrete, battle-tested patterns. Make context explicit and portable. Wherever possible, move context into the data itself. Instead of assuming a global time zone, include a TZ field. Instead of leaving currency implicit, use a currency code column. When records carry their qualifiers, downstream systems can make correct transformations. Attach producer metadata and lineage. Record which pipeline, service, or sensor produced each datum and when. Lineage systems give you the provenance needed to reconstruct context. They also help diagnose when context changed. Use qualified names and namespaces. Namespacing makes context part of the identifier. That reduces misinterpretation when datasets are merged. Version schemas and publish changelogs. When semantics change, make it an event. Semantic versioning for schemas, combined with changelogs and migration notes, transforms invisible shifts into discoverable, managed transitions. Write context-aware validation tests. Don't only check types and ranges. Test expectations that depend on context. Tests encode implicit assumptions. They catch mismatches early. Catalog usage examples. Data catalogs are not just lists of fields. They should surface example records, typical queries, and consumer notes. Seeing how a field is actually used gives clues to its contextual meaning. Treat context as a first-class citizen in ML. Models trained on data from one context often fail when deployed in another. Make your feature engineering context-aware. Include source identifiers as features or train separate models per context. Monitor model inputs for shifts in contextual distribution. Set up alerts when those shifts occur. Enable human-in-the-loop disambiguation. Some contexts are too nuanced to fully automate. Build lightweight interfaces for domain experts to tag or confirm ambiguous records. Capture those decisions as metadata. That knowledge improves automation later. Now a word about detection. How do you know when context is being misapplied? Look for these signals: sudden distribution shifts, inexplicable drops in model performance, anomalies that align with a deployment or schema change, or an increase in data incidents. Lineage and monitoring make these signals actionable. You can trace a spike to a particular source and see whether its context changed. Finally, think about context dependence as an opportunity, not just a liability. Context is rich semantic information that, when captured and modeled well, can make your systems smarter. Contextual features improve models. Provenance enables better debugging. Portable context supports safe reuse of data across teams. To close, return to the word spring. If that word sits next to garden event, you think seasons. If it sits with mechanical part, you think coils. Data is the same. Meaning is not a property of a single token. It's a relationship between that token and its context. Your job as a data designer, engineer, or consumer is to make that relationship visible, verifiable, and resilient.